Now, what is a free body diagram? Free body diagrams are simplified diagrams to show the magnitude and direction of forces acting on an object. They involve the use of simple boxes and arrows. Plus, the direction of the arrows shows the direction of the forces acting on the object. Now, one thing to keep in mind is that the arrows have to be in scale, meaning that they have to be proportionate to each other. Another thing to know is that vector resolution simply means finding the net force. So how do we start making a free body diagram? Now let's use the Chevrolet Corvette Stingray concept as an example. The first step is simple. All you have to do is turn the object, or in this case the car, into a box. For the next step, all you have to do is add the force vectors. Now let's just say that the car broke down and you push the car 1 Newton to the right. It's already going 5 Newtons. So now all you have to do is find the vector resolution. Now the third step is to calculate the FR, or the net force, basically the resulting force. The result of the net force would be the amount of newtons you're pushing the car and the amount of newtons the car is going added together. So since they're going in the same direction, it's basically simple addition. 1 plus 5, which is 6. Now let's look at a different example from Mr. Anderson. As you can see, there's a bottle of wine that's just on a table. So if we want to draw a free body diagram, we have to first convert that wine into a simple box. After that, we add in the force vector. Now, since it's not moving, there's only 2. The force vector for gravity, and then normal force, which is going in the opposite direction. This is because of Newton's third law, which states that for every action, in this case gravity, there is an equal reaction going in the opposite direction, which is normal force. This is why the bottle of wine is perfectly still, or is basically balanced. Now let's try making a free body diagram based on the clip of Unstoppable that we saw in class.
1206, this is Connie Hooper, you there?
1206, over.
Just wanted to see how you boys are doing.
We're doing about 60 miles an hour, Connie.
Sorry? Frank, I don't understand.
We're going after your train.
1206, I'm not hearing you.
The rear knuckle was left open, so if we can catch up, we can tie it on around locomotive. Try and slow down 777.
Frank, you can't.
We already are.
That train's carrying 30,000 gallons of toxic chemicals. They had a window before, but that train's going into populated areas. There's no way they derail it now.
Are you sure about that?
Now, based on what we just saw, what's the first step? Bingo! Turning that train into a box. Now all we have to do is add the force vectors. Now instead of going miles per hour, let's just focus on force and say that the train is going 65 newtons, but then the overall force is 60 newtons. So in order to go to the third step, we need to determine which force we're trying to find. In this case, the force that's pulling the train back, the resistive force, which in this case could be friction. Now using simple algebra, we can set up the equation that net force is equal to the sum of force 1 and force 2. After doing the math, we'll find out that the force pulling the train back is actually just -5 force. Now in this example, the forces are unbalanced because the train is still able to go at a fast speed, accelerating. And this concludes our video. Thank you for watching.